Good morning, everyone. So today we will start with the module 4. So supercharger, turbocharger, and fuel supply system. So in this class, today we will cover with the supercharger and turbocharger part, and in the next class we will cover with the fuel supply system. So first we go for the syllabus of this module. What it states syllabus. So in the supercharger and turbocharger part, first we will discuss briefly about what you mean by naturally aspirated engine, then how supercharger will improve the power output of the engine, that is by forced induction method, and the types of superchargers and methods of supercharging, how you can achieve that supercharger, so that methods and different types of superchargers, especially based on your compressor type. We will have different types of superchargers. Then we will go for the turbocharger part. So we will explain the how we are going to construct that turbocharger and its operation, its working principle behind that one. Then why you need that intercooler. Then we will go for the turbocharger lag. So these are the portions we will cover in supercharger and turbocharger. Then we will go for the convention fuels and fuel supply system for both SI and CI engine. Already this part already you have gone through in the module 1, that is different types of conventional fuels and alternative fuels. Already I have covered this part in module 1, so once again I am not going to cover this part, that is conventional fuels and alternative fuels, as well as normal and abnormal combustion, C10 and octane number. So this part already I have covered in the module 1. So hence this part I am not going to deal with. So only this part I will go through. Before going for any fuel supply system, you should know how much range with respect to air, that is called as mixture requirement for SI engine, because we are preparing the mixture outside the engine, and for mixture requirement for SI engine is very much essential. So how much metering of the fuel we will call it as, so that is essential part of the SI engine. And we will go for that conditions, then objectives. Then we will go for carburetor. Nowadays carburetor are absolute, especially in bikes only we are going to find, or even in old cars only we are going to find out this carburetor. After a few years I think carburetor will be absolute in the bike also. So already in the bikes they have started a fuel injection system. As soon as you enter in bar stage 6, I think this carburetor will vanish. So just according to the syllabus, they will have the carburetors, different types of carburetor. Then we will come into the injection system, fuel injection system for SI engine, that is multi-point fuel injection system and single point fuel injection system, very much needed for you nowadays, because already all the cars and bikes they have started with the fuel injection system, and so this part you are going to study. Then we will go for the CI engine fuel supply system. So in this we will have the fuel pumps, fuel filters, fuel injection injectors, all those things will come into picture. So because we are pressurizing the fuel at a very high pressure compared to SI engine. In SI engine only up to 3 or 4 bar pressure we are injecting the fuel, whereas in CI engine we are injecting the fuel and around 200 240 bars. So nowadays in CIDI system we will have 1500 bars fuel injection, so pressure. So that much pressure we have to create in the fuel, because we have to atomize that fuel, and combustion has to initiate by itself. And so pressurizing the fuel means atomizing the fuel is very much essential in CI engine. And we have to go for higher pressure of fuel injection. So hence CI engine, these parts are very important, that is fuel injection pump and injectors. These parts are very crucial over here. So then we will go for electronic injection system, that is common rail diesel injection system. So these are the things they are using in the heavy duty vehicles, even in cars also they are using, but heavy duty vehicles they are more commonly they are using common rail diesel injection system. And XUVs, all those things they will use CIDA engine system. Okay, so these are the syllabus of your module 4. So today we'll cover with the supercharger and turbocharger part. So whenever you talk about supercharger and turbocharger, before that, how engine will works. For example, if you take SI engine or CI engine, air and if you take now particularly for SI engine, air and fuel in the intake manifold, it will prefers the mixture and charge will becomes. That charge will come inside the cylinder during the suction stroke. Okay, then the compression will happen, combustion will happen, then power will be produced, then exhaust will be there. So now this is for some amount of air along with the fuel. So now if we want to increase that power output, how we can achieve that power output increase in power output? We can several ways we can improve that power output. One is amount of air induced in the cylinder per cycle. That means the mass of air. Whether if you want to increase the mass of air, because whenever you increase the mass of air, what will happen? The density will becomes more, or sorry, not density, oxygen content in the mass will become more. So hence fuel will get sufficient oxygen, as power output, combustion will be better rate, hence power output can be increased. So that is the one parameter where you can use the power output can be increased, that is the amount of air introduced inside the cylinder. So this is nothing but your volumetric efficiency. So this part is tells about your volumetric efficiency. While increasing your volumetric efficiency, what will happen? Your power output can be increased. Next one is degree of utilization of inducted air. So whatever inducted air is there, so that has to be participated in the combustion. That means the oxygen present in the air, it has to participate in the combustion. Sometimes what will happen, all the air whatever present inside the cylinder may not participate in the combustion. That is some air will be wasted as it is. So how much utilization you can make inside the combustion chamber, so that will becomes a power output can be increased. That is the second parameter where you can increase the power output. Next one is the engine speed, because as the engine speed increases, what will happen? The suction, more suction pressure will be there, so more amount of air it can induce inside the cylinder, hence power output can be increased. Next one is the thermal efficiency of the engine and quantity of fuel admitted and its combustion characteristics. So these are the things. Thermal efficiency means that is nothing but fuel consumption. It will tells about energy conversion factor. That is whatever the chemical energy is there, how you will get converted into mechanical energy. So that is the conversion factor, thermal efficiency. Then the quantity of fuel admitted and its combustion characteristics, that is if the fuel is having higher calorific value, or it will have the less viscosity, all those things, the quality of the fuel admitted. So these two things, the last two things, whatever you are told, so this will be, it can change by the engine design, because you have to change by engine design only, you have to change, otherwise it is a bit difficult, the second part and fourth and fifth. The only thing, without changing the engine design, what we can do, that is amount of air can be increased or engine speed can be increased depending upon the condition. So because these three factors, the no, thermal efficiency, quantity of fuel, this will also depends upon your thermal stress of the engine materials, or it can base the thermal load, and it is difficult to change this one for after a certain limit. So hence we can change the amount of air, or engine speed can be increased. By doing that, we can increase the power output of the engine. How we have to do that one? That is nothing but your supercharging. So that is one of the method, that is the amount of air whatever you are introducing inside the cylinder, we have to increase that amount of air. That is nothing but your supercharging. So, and also you are talking about engine speed. So what will happen, as the engine speed increases, inertial load will increases, and this will cause for rigid or robust engine design to withstand that stress. So engine speed also we can avoid as much as possible, because more speed means the inertial load will come into picture, then the material rigidity, and robust engine has to be designed to withstand that kind of stresses. Okay, so this is how engine speed also it is can be avoided. Also, as the engine speed increases, what will happen, because there is a less time, hence amount of air introduced inside the cylinder may decrease. That means volumetric efficiency might be decreased because of its higher friction or bearing loads. So only one possible way we have left to increase the power without changing much in the engine component size, that is the amount of air introduced inside the method. Okay, so how you can increase the method, that is the we have to increase the air density by supercharging. So if you want to increase the air density, how you can increase that air density, how we can achieve that air density increasement, that we are going to study over in this module. Okay, so the method of increasing the air density is called as supercharging of the engine. So while air density increases, that is the amount of air going inside the cylinder will increases. That is nothing but once air amount is increased, then the power output, that is volumetric efficiency of the engine will increases. Once volumetric efficiency is increases, then power output of the engine also can be increased. So supercharging is achieved by supply air or air fuel mixture at a pressure higher than the pressure at which engine naturally aspirate the air. For example, if you have a normal engine without supercharging, it will suction the air at the normal atmospheric pressure. Okay, so normal atmospheric pressure, it will suck the air. So that is called as naturally aspirated engine. So without any kind of increase in the density, if air is going to be inside the cylinder at a normal pressure, that is 1 atmospheric pressure, then that kind of engine it is called as naturally aspirated engine. If if naturally aspirated engine, for that if you add that supercharger, what will happen, it will increases the pressure of the air. So while increasing the pressure, what will happen, the density of the air or air fuel mixture also become more. The density will become more, air density of air will become more. That means more amount of air can be introduced inside the cylinder. That is nothing but the supercharged engine. That is nothing but supercharged engine. So while doing this, while increasing the air density, hence mass of the air will increases. That is mass of air for the same swept volume, which will increases, thereby increases the power output of the engine. So while increasing the density, mass of air will be increases, so it will increases the power output of the engine. So that means while increasing the air density, your volumetric efficiency is going to be increased. So more amount of air will be introduced inside the cylinder, so hence the power output can be increased. So whatever device we are used to increase this air density by increasing its pressure, that device is known as supercharger. Remember, so supercharger is used to increase the pressure of air, so thereby we are going to increase the density of air and power output of the engine. So this is the main concept behind your supercharging. Okay, and power output can also increases the thermal efficiency. Once the power output is increases, that means obviously your thermal efficiency also increases, because thermal efficiency is nothing but your power output by power input. So power output, if it is increased for same amount of input, then obviously thermal efficiency has to be increases. So however, this increases might be limited to some cylinder pressure, because we can't go beyond certain limit, right? So engine has to be designed for particular pressure range or a maximum pressure limit. So we can't give the more pressure, more amount of air inside the cylinder. So that it should be limited to for your maximum pressure cylinder pressure, okay, or maximum brake mean effective pressure. So this rate of increase of maximum cylinder pressure should be less than that of rate of increase in the brake mean effective pressure in case of the supercharger engine. That means we want to increase the power output, so whatever maximum pressure you are getting while supercharging, that should be less than that of your brake mean effective pressure. That is the meaning of this sentence. So whatever you are giving pressurize for your cylinder pressure, means air. So whenever combustion take place, the combustion pressure will happen, that should be less than that of brake mean effective pressure. So this means that for a given maximum cylinder pressure, more power can be obtained by supercharging when compared to that of obtained in the normal case, when same compression ratio we are going to use. So rate of increase in maximum temperature also low in case of supercharging, hence it will results in the lower thermal load. So this is how we can achieve your supercharge, okay. So whenever you supercharging has to be done, it will increases the compression ratio also, and increases the exhaust gas temperature also, which will results in higher thermal loads. But turbocharging, whatever the turbocharging will come in the next also, next few slide later, turbocharging will uses this exhaust energy, and so that will increases air density, that will reduces your thermal load, okay. So this is about your supercharging introduction. Now we will go for the forced. So forced induction is nothing but it is a process of delivering the compressed air to the intake of an IC engine. Means we are increasing the pressure by compressing the air. So how we are going to that uh, introduced inside the intake manifold? So this is the process. Forcibly we are inducting the air inside the engine. So to do this one, we will use one gas compressor to increase the pressure, temperature and density of the air. So one instrument we are going to use, that is the compressor, gas compressor, to increase the pressure, temperature and density of the air. So an engine without the forced conduction is called as a naturally aspirated engine. Means normally it will take the air as it is by sucking, that is 1 atmospheric. That type of engine it is called as naturally aspirated engine. Forced induction engine means we are forcibly making that higher pressure, air density. So some device we will use. So then that type of engine is called as forced induction engine. So forced induction is used in the automotive and aviation industries. So many automotive and aviation industry, they have to use only because they have to get more power, and efficiency also they can be increased by forced induction method. We are forcibly inducing the air, that is the max density of air, we are forcibly increasing the air, so that the quantity of air going inside the engine cylinder will increases. So forced induction engine, essentially two compressor will be there in series, sometimes depending upon the type of pressure you needed. If you wanted more pressure, so then two compressor they may use, or usually we can see in your vehicle only one compressor will be there. So depending upon the types of pressure you require. So compression stroke of the engine is the main compression that every engine has. An additional compressor feeding into the intake manifold makes the forced injection. So compression always will be there in the normal case of the engine, but along with that one more compressor we are going to add outside in the intake manifold, so that we are feeding the air more than the 1 atmospheric pressure. So okay, a compressor feeding pressure into the another, which will greatly increases the total compression ratio of the entire system. So while doing this one, what will happen? Your pressure will increases, also compression ratio also of the engine will increases. So whatever pressure it is increased from the normal pressure, then that pressure is called as boost pressure. Remember the intake pressure, so which will be higher than that of your normal atmospheric pressure, that pressure is known as boost pressure. We are boosting that pressure so that the amount of air going to be inside the cylinder will increases. So this particularly especially in aviation engine, it will helps as soon as they have to operate in a high altitude range. So it will, this boost pressure will helps greatly in the aviation industry. So these higher compression engines have the benefit of maximizing the amount of energy extracted per unit of fuel, because whenever we put a higher energy, mass will increases. That means oxygen content in the air is going to increase. More oxygen will be provided for the fuel, and so better combustion can be achieved while increasing the pressure of the air. So hence whatever energy of the fuel will be there, that more energy can be utilized. Hence what will happen? When the more energy can be utilized, more power output will come into picture. That means thermal efficiency of the engine can be increased. Okay, so that is the main advantage of your system, that is supercharger or forced induction system. The so in such cases we can use the engine at higher compression ratio, but problem is that is the knocking problem may come into picture. So that for that reason, we can't go for the higher compression ratio. So that is the one thing we can note down that one, because higher compression ratio cannot be used because of the knocking limits of the engine, because that may lead into the pre-ignition or any other kind of damages of the engine engine materials. So high compression or naturally aspirated engine can reach the detonation threshold fairly easily. Okay, however, so forced injection can be have the higher total compression without detonation, because air charge can be cooled after the first stage of compression, that is by using the intercooler. That means one device we are using like compressor, so what will does, it will increases the pressure in, after increasing the pressure, what will happen, temperature also increases usually. So what will happen, so we will place one intercooler, one device. What it will does, it will reduces the temperature and bring back the temperature to the normal condition without losing the pressure. Hence intercooler will be placed after the compressor, so that temperature can be initial temperature, and pressure can be higher pressure, that is the boost pressure. So here our primary concern is in IC engine is the boosting the pressure. While boosting the pressure, nowadays we have to check emission part also. While boosting the pressure, what will happen, combustion is going to be better than the naturally aspirated engine. So while naturally aspirated engine we are getting the better combustion, means in completion of hydrocarbon fuel or CO emission formation might be lesser, but the problem is NOx emission, that is oxides of nitrogen. So this oxides of nitrogen, the formation of this is mainly depends upon the temperature and the oxygen content. Okay, now we are providing more oxygen to the engine. What will happen? Then formation of the NOx also will become more. That is the one major issues we have to take care while introducing into the supercharger or turbocharger in your system. Okay, so that part has to be taken care, because high combustion temperature as well as your high oxygen content in your combustion chamber will lead into the high formation of the NOx emission, and so that part has to be taken care very effectively. Okay, so this is about your post induction system. Next we will move on to the particular for supercharger. So supercharger means we will have one air compressor, means one compressor device we have to use so that pressure of the air can be increased, or we have to boost that atmospheric pressure. So this gives each intake cycle as a more oxygen, that only we are going to tell from that time onwards, that is more oxygen is available, else more amount of fuel can be burned, means unburned hydrocarbon will be becomes very less in the exhaust, so more amount of fuel can be burned, and so power can be increased. So power of the supercharger can be provided by mechanical means, that is belt, gear, shaft or chain connected to the engine crankshaft. That means we are using this compressor. So for this compressor it is a power input device, so we should give the power. How to give the power? It has to give from the engine itself, that is from either engine crankshaft, the some amount of power it has to be transferred to this supercharger. So we should make sure that whatever, while introducing this supercharger, whatever power is to be produced, it should be more power, so that only air compressor should get only little consumption of the power, that I have to make sure. So this has to be given by belt, gear, shaft and chain connected to the engine crankshaft. When power is produced by the turbine, that is nothing but your turbocharger. So turbocharger also a type of your supercharger. So in the turbocharger we are utilizing one turbine we are providing. So that turbine what will does, it will run by your exhaust gas. So means we are not using any power input from your engine, we are using power input from the exhaust gas. So exhaust gas turbine will run, that shaft is coupled to the compressor, that is your supercharger. So in this way we are going to the power input for charging your air. So this is how we will do either supercharger or turbocharger. Uh, Now we will go for uh, general points to be noted in your general points to be noted in your supercharging. So generally this supercharger will work with the gear ratio that has to be created from the desired speed of the impeller. If you require the boost pressure is very less, then a larger drive fully can be interchanged onto supercharger. So that means only few like from 1 atmosphere to you need only 1.1, 1.2, very less boosting pressure. If you require that larger drive, it can be interchanged onto supercharger. If more boost pressure is needed, then smaller pulley can be used. So however, these boost levels can be controlled by other ways too also, because so this is one of the way. Other ways like a gear mechanism or turbine mechanism or turbocharger, through that also, or gate valves we can use. So from that also you can control your boosting the pressure. So wastegate or blow off valves, so many ways you can control that boosting of the pressure. Next, the point should be noted down during the supercharging. First one is to increase the power output. That is the main intention of your supercharger, what you will call. So that is the main intention of your supercharger, has to be increase the power output of the engine. Supercharging, which results in higher forces, because air density is more, and the pressure created inside the cylinder is more, and combustion pressure really increases because more amount of fuel can be burned along with the air, more air. So air quantity increased, combustion pressure will be increases, hence that engine should design to be stand this kind of forces, especially thermal forces, thermal loads, whatever it will create depending upon supercharging pressure ratios. So the engine should bear that load. So that also we have to take care. The power required for the air compression has to be taken care from the engine itself. So this is another thing, because we need a power input for that compressor, so that power has to be taken from the engine itself. So the net power output should be more than that of whatever power output we are getting from the naturally aspirated engine. So net power out should be always should be greater than your naturally aspirated engine. Okay, so this is the third point we have to consider. Then the fourth point will be the high pressure and temperature may lead into detonation. So supercharging, the boosting the pressure, how much you have to boost, that has to be decided properly, because higher the boost pressure, it may lead into the detonation or knocking, and so engine life can be reduced. So we have to take care about that detonation as well as knocking of the engine with respect to your boost pressure. So this is how you are going to note down all the points when you are changing naturally aspirated into supercharger engine or post induction engine. So how this is how we should point should be noted down. So now we will go for the objectives of this supercharger. So objective, so supercharging is to be done for a more amount of oxygen or more amount of air should be going inside the cylinder per unit time, and so more amount of fuel can be burned so that power input can be increased. So objective of the supercharging, so for a given weight and bulk of the engine, supercharging has to increase the power output. So this is the objective of your supercharging. For the given weight and bulk of the engine, supercharging increases the power output. This is important in aircraft, marine or automotive engine where weight and space are considered. Very importantly in your aircraft or engines, where high altitude you are going to work, and weight we want to reduce, but we want need more power output, so supercharging has to be done. So objective is the for given weight or bulk of the engine, supercharging has to increase the power output. Next, to better performance from the existing engine. So this is the second uh, objective of the supercharging, and third one is the to compensate loss of power due to high altitudes for a aircraft engine. So whatever loss of power will be there, that has to be compensated from this supercharging device. So these are the three objectives of your supercharging engine. So whenever you talk about air loss of the power in the aircraft engine, it might be approximate rate of 1% of 100-meter altitude. That means for each 100-meter altitude, we may get 1% loss in the power. So as the altitude becomes very high and high, the percentage of loss will becomes more and more, and so that loss has to be compensated. That has to be done by this supercharging method. So this also relevant in other engine also, which used in high altitude. So this is the third one, is very important whenever you using for high altitude engine, so that supercharging can compensate that power loss. Okay, next we will go for briefly advantage and disadvantage of supercharging. Advantage, what are the advantage you can get generally? So generally we can say that uh, power output, it can be increased. Power output of the engine can be increased, and more quality of fuel or quantity of fuel can be burned properly. Means we will get the more power output, so more quantity of fuel can be burned inside the engine cylinder. So better atomization in case of CI engine. What will happen? Atomization of fuel will be very much important, because fine particle of fuel has to be there inside the combustion chamber, and so this supercharging, what will do, more density will be there, hence swirl generation will be more while supercharging, hence atomization of fuel will become very easy in CI engine. So better atomization can be obtained by the supercharging of the engine. Next, better mixing of air and fuel can be obtained. In SI engine, we are mixing the fuel outside the engine. Hence, while supercharging, what will happen? Density is more, hence the fuel will can combine with the air in a better way compared to that of a naturally aspirated engine. Then the better scavenging of the exhaust gas is possible, because more pressurized air will coming inside the cylinder, and it will push us the most of the exhaust gas to the exhaust manifold. Hence scavenging of the exhaust gas is very much effective whenever you are using the supercharged engine. So this is one of the big advantage. Scavenging can be done, so that while scavenging, what will happen, the pre-ignition of the fuel can be avoided. So this is the one another advantage, inside advantage. Better scavenging means pre-ignition can be avoided. Then torque can be improved for the same speed range, or better torque can be obtained at a lower speed because of the more power output or more fuel combustion. Then specific fuel consumption can be, or forced acceleration will be there, or faster acceleration of the engine can be possible. Then the specific fuel consumption can be lower slightly, because it you can see that it will have a better combustion, and to get that power, the lesser fuel. Whenever you say for naturally aspirated engine, if you want to go at 2000 rpm, it may take 1.5 kg per hour of fuel, because unburnt hydrocarbon will be there, means most of the fuel may not be participated in your combustion. If you are adding supercharger to achieve that same speed or same power output, so you may require lesser fuel, that is 1.2 or 1 kg, because of more proper combustion or better combustion compared to that of naturally aspirated engine. So hence fuel consumption can be slightly lower whenever supercharging has to be done. So this is another advantage. Then better mechanical efficiency, obviously, because power output is going to increase, BP going to increase, hence mechanical efficiency has to be increased, and efficiency of the efficiency combustion is possible. Uh, then we have 10th one is in CI engine, exhaust smoke can be reduced. Smoke can be reduced. So this is the another advantage. So these are the advantage of supercharging. Okay. Whenever you have the advantage, obviously disadvantage should be there along with that. So we will go for the disadvantage of this supercharging. Disadvantages: detonation, especially in CI engine. So detonation may increase while supercharging. So this is the one of the disadvantage, so that more boost pressure cannot be done in a sign only 1.3, up to 1.3 only you can use, so that power output can increase. Beyond that, it may lead into the detonation. Once detonation is formed, that means the life of the engine is reduced. More damage in the materials can be obtained. So this is about detonation problem while using the supercharging. Then heat loss due to turbulence and turbo stresses are more. So heat loss will be more, and thermal stresses, especially because more pressure will be there, and so more heat energy will come into picture. So your materials to withstand that thermal stress at higher temperature, so that may lead into problem. So that is another disadvantage of this system. Then third one is the valve overlap period. That is nothing but intake and exhaust. Because of higher pressure, your valve might be designed for 180 atmospheric pressure, so valve overlap period may increase up to 63-degree angle, which is not desirable condition, because your charge may go along with the exhaust. That might be a loss of fuel quantity or air quantity along with the exhaust gas, if the valve overlap period is increased. So that might be the another disadvantage. Then better lubrication is required, because for same quantity of fuel we are getting the more power output, and so movement of the mechanical linkages will be more, and so better lubrication will be required. Then heat production is more for the same amount or same speed. Heat production is more, that means the most of the material will go into the thermal stress, and heat losses or high temperature it will encounter, and so cooling of the piston and valves are required. So very good quality of cooling is should be required. So cooling system has to be improved. So that may lead into disadvantage stage of your supercharging. Next, we are adding some system inside the engine, that is intake manifold. We are increasing the compressor, some linkages to drive that compressor, or some power input. Hence, it will lead into the cost. So increase in the cost, total cost may happen due to supercharging. So these are the disadvantage of your supercharging system. Next, we will check what are the methods we can do for a supercharging. Four methods are there. We can achieve that supercharging. So some modification might be required. Some addition of the element should be there along with the engine, or like that. So many methods we can do for supercharging. So there will be a number of ways we can achieve the supercharging methods. So supercharger may be run by engine through gear. So whatever the engine produces the power, so that supercharger element can that run through engine through gas. Alternatively, or exhaust gases can be used to run that compressor. So there are four types will be there in that first type, that is supercharging with the turbine driven engine compressor. Sorry, it is not turbine driven, it is supercharging with the engine driven by engine compressor. So okay, so in this we will have the engine with compressor. So compressor will be run by engine power. Remember, this compressor is run by engine power through the gear mechanism. So coupled with the engine, this compressor is coupled with the engine with the setup gearbox. So gearbox will be there. So depending upon the gear ratio, it will run. Then the part of the engine power output is used to run this compressor. So net output can be increased. Net output might be increased, but the part of the power has to be driven to compressor. So this is the how your settings will be there. So what will happen, this compressor, your air will comes at a normal atmospheric pressure, it will compresses. After compresses, your pressure and temperature will increases. So to reduce the temperature, we have the aftercooler or intercooler. What is the function of intercooler? It has to receive the, or it is take the heat from this charge compressed air, so bring back this temperature to the normal temperature, that is the initial temperature. Then it is fed back to the engine. This will be the exhaust. 1 to 2 is compression, your pressure will rise. 2 to 3, pressure will remain constant but temperature decreases to the initial condition. Then initial condition temperature and pressurized air, it is going through the engine, so where the power output can be increased. So in this way we can have the supercharging with the engine driven compressor. So this is about supercharging with the engine driven compressor. Okay, so next one we will have the next method. We'll go next method. Next method will be supercharging with the turbine driven by engine exhaust. See over here the diagram. So this is the intake, this will be the engine. So this will be the intake and this will be the exhaust. In the first case, engine power has to be utilized. In the second case, exhaust is there, no? Exhaust, from the exhaust energy we are running the turbine. One turbine will be there. So we are running the turbine. So this turbine shaft is coupled to compressor. So that means with the exhaust energy we are utilizing the that energy to run the compressor, so through turbine. So turbine will run, turbine will couple to compressor, and hence compressor will run. So the compressor turbine is used independent of engine, as no connection with the engine except your exhaust pipe and the air inlet pipe. So engine power doesn't give any kind of power to any other component of your supercharger. So turbine power is used to run the compressor. So turbine power is obtained from the exhaust energy. So this is how your second way of doing the supercharger. So this is called as turbocharging. We will go through later stage. So this will run the compressor. So pressurized air will come into the intercooler. So what it does? Pressure will remain constant. Temperature will this is, so temperature will become the original temperature. Then it is fed back to the engine. So this is how we are going to do the supercharging by second method. That is turbo supercharging with the turbine driven engine exhaust. Next one we will have the third method. So in this method, supercharging arrangement in which engine, turbines and compressors are coupled. See, we can see over here, engine power also is there, then exhaust power also is there to run the turbine, then turbine is runs the compressor. So both the powers, exhaust power as well as engine power, it is utilized. So in the third arrangement, engine, turbine, compressor all are coupled with the gearing. So this will be coupled with the gearing together. If the output of the turbine is not sufficient to run the compressor, so that means initial stage, the at the lower speed, you don't have that much energy, exhaust energy, to run this turbine. So whenever this exhaust energy is not sufficient to run the compressor, so then we are using this gearing mechanism, that is from the engine we are running the turbine then to the compressor. So some part of the engine power is used, especially this can be happening in the part load condition. At part loads, engine can provide this additional power to the turbine, and turbine will develop more power to compress the air. So this can be fed into the engine. The compressed air can be fed into the engine through the intercooler. So this turbocharged two-stroke engine requires the assistance of mechanically driven scavenging blower under the part load condition. Therefore, sometimes turbocharger is coupled to engine so as to supply the necessary air at the part load condition. So this one can be used during the part load condition. So first case, what we have? First case only engine driven, second case only exhaust driven. Now we will have the engine driven plus exhaust driven both, because at higher speed exhaust energy is sufficient to run the compressor, but at part load we need some kind of engine power also to run the compressor. So both the energy we can use in. Okay, this is about third method. Then fourth method is that. So fourth method, what it does, we'll, we'll see that one. This is the fourth method. So supercharging is done in engine runs the compressor and turbine develops the power. Okay, that means see here power is developed in the turbine. So this method is very rarely we are using, but this is one of the other method where you can use. See, whatever compressor is there, that power is produced from the engine. Okay, but actual power we are getting in the turbine. All the power it is getting in the turbine. So this is about fourth method. Okay, so in the fourth method, what will happen? In this arrangement, engine supplies, see, engine supplies total power to the compressor. Whatever engine power has been produced, that has to be given to the compressor, and the exhaust gas, whatever produced over here, exhaust gas from the engine, which will drives the turbine to give the power output. So power output is we are obtaining over here. So whatever power produced in the engine, it will be utilized to run the compressor, and extra every power it is given to the turbine. So at the turbine output we are getting the power output. So such plants, such kind of plants, it is called as pre-piston engine. Pre-piston engine. So in this engine, one limitation is the thermal efficiency directly related to boost pressure, how much boost you can do. So that will depends thermal efficiency. So if the boost pressure is more, your thermal efficiency also more. If the boost pressure is less, your thermal efficiency also less. So this boost pressure ratio will be reduced in the lower loads or part load condition. During that boost pressure is less, and thermal efficiency might be less in the part load condition. For loads below 25%, say 10% or 20% of load, so we require more amount of gas or more amount of fuel has to be blown, so that turbine cannot run below certain pressure. So that is the limitation we are having in this case. So in this case, uh, engine is produced to power that is given to compressor. All the engine power is given to compressor, and rest power output will be given from the turbine. Okay, so engine power, it is coupled to gearing to the compressor. Compressor will compress air, then it is going to the intercooler. Intercooler, what it does? At constant pressure, it will reject the heat, then it is going inside the engine. Combustion take place, exhaust will be given to the turbine, so which will drive the turbine, and power output we are getting on the turbine. So this is how your fourth method has to be done, that is the supercharging method. So these are the four methods we are using in the supercharging. So usually second methods and first methods are commonly used, very widely used type of superchargers. Okay, next we will go for types of supercharger. Next we will go for the types of superchargers. Whenever you talk about types of supercharger, that mainly depends upon which type of compressor you are going to use. So types of supercharger means it is basically nothing but types of compressor itself. Okay, you have already gone through all those things, the type of compressors in your earlier subjects. So types of compressor we will have the reciprocating type, rotary type, centrifugal type, root blower type, and vane type of compressor. All those things we have already gone through. So here we are mainly concentrating about centrifugal type, rotary type, and vane type. Reciprocating we are not going to use because we need sometimes energy from exhaust gas to run. So reciprocating will lead into some kind of problem because it might be bulky in nature, and lower power we may not be transferred, lower pressure ratio it cannot be transferred properly, and that all the problems will be there in the reciprocating motion. So and also it is very bulky and heavy in nature, so you may require higher booster pressure, then only we can go for reciprocating compressor, and cost also very high reciprocating for this kind of things, which may not be suitable, or cost may not be justified for reciprocating type. And rotary types are very commonly used types of supercharger. In this we have three types, we are broadly we will classify, that is, one is centrifugal type, one more is the root blower type, and one more is the vane blower type. Okay, so before that, one clarification or one thing we have to remember: if engine crankshaft drives the supercharger, then it is called as mechanical supercharger. Remember, mechanical supercharger means if engine crankshaft, remember engine crankshaft, if that drives your supercharger or compressor, then it is called as mechanical supercharger. Remember, if the supercharger is driven by the gas turbine which runs on exhaust gas of the engine, means from the exhaust gas, if it is runs the turbine and turbine is coupled to the your compressor, then it is called as turbocharger. Remember, what is the difference between turbocharger and mechanical supercharger? In the mechanical supercharger, compressor or supercharger is run by engine crankshaft, whereas in a turbocharger your compressor or supercharger is run by turbine, which in turn runs by exhaust gas energy of the engine. So this is the major difference between your turbocharger and a mechanical supercharger, that you have to remember. Now we have the um, three types of supercharger. One is the centrifugal type, second one is the root blower type, third one is the vane blower type. Now we will look into the centrifugal type of compressors. So we can see over here in the centrifugal type figure shows, this is the actual figure. So we will have the impeller, we will have the then diffuser, we will have diffuser is to just to provide the direction for air. Then we will have the compressed this one volute casing will be there. volute casing, you just check the this one is coming, air will coming, so as you coming out, your area is keep on increases. So suction will take place at the center. So axial entry, radial outlet. So figure shows your centrifugal compressor, which consists of impeller rotating on a closed fitting casing. So closed fitting casing will be there. The air enters the above the impeller axially. So axial entry will be there above the end, above your above. This one is called a up. So you have seen this one in turbo machine. So at the above the end impeller, your axial entry will be there, and it is turned 90 degree, exactly 90 degree. It is rotated by the vanes or impeller, radial impeller or diffuser ring. Okay, a high velocity imparted uh, to the air due to centrifugal action, because rotation will be there your impeller, and high velocity will be imparted to the air due to centrifugal action, and high velocity air at the tip of the radial vanes is faster to the tip of your radial vane, it is fast through the diffuser or volute casing. Okay, where the pressure is raised and this air is supplied to the engine. So diffuser will give the direction for this air, and then it is going inside the compressed air will be going inside your centrifugal. Okay, this centrifugal compressor runs at very high speed, approximately in the range of 15 to 20,000 rpm. So for a low speed engine, and sorry, 10 to 15,000 for low speed engine, and 15 to 30,000 rpm for a high speed engine. So actually we have done the experiment during my PG, that is MTech. I have done that turbocharger. So we have checked volute casing, how the air flows will be there inside this turbocharger. So we have checked, actually we have checked the speed. We have achieved high speed engine in CI engine we are used to. So this speed what we have got is around 45,000, 7,000 rpm we have got at high load. That means at maximum condition we have achieved 45,000 rpm, which is very dangerous, that rpm, because that much air will be compressed. So we have to take care of that one. So many things we can do. ANSYS analysis you can do, airflow analysis you can do, thermal analysis you can do on this thing without cost effective manner, means through the software you can analyze everything, flow analysis, all those things you can analyze. So this is a very good work if you do the mini project work related to superchargers or turbochargers. Okay, now leave about that one. The compressor can be driven by the engine through gearing. So this can be by the gearing mechanism through the engine crankshaft you can run, or might be exhaust driven, that is a turbocharger. So in case of mechanically driven compressor, high set of gear is required. Remember, so we have to check the proper gear ratio so that it has to match the engine speed. Okay. Then centrifugal compressor is simple in nature when compared to reciprocating. It is a small case, means it not a bulky in nature, very small, cheap also, and has a good efficiency in the range of pressure ratio range of 1.5 to 2. So which is commonly used supercharging, and about 70 to 80% isentropic efficiency will be can be achieved with a pressure ratio of 2 is to 1, and a very high pressure ratio can be obtained in a single stage, so that weight of the compressor is usually 0.6 to 1% of the dry engine weight. So mechanical efficiency we can achieve around 90 to 95% of the dry engine when compared to good design. So these are the advantage we will get on a centrifugal type of supercharger. Okay, uh, next this we will go for uh, next type of this one charger, that is nothing but your roots blower. So this is how your casing will be there. So impeller. So this will runs. So your charge will be there. Second case. then it will move on the volute casing through the diffuser, then it will goes like this, like this, like this, and it will goes to the your compressor, means to the engine. Compressed air is going to the engine. This is how your flow chart you can say for a centrifugal type of supercharger. So what are the advantage we can see over here? Advantage: initial cost is low, and power input requirement is less when compared to that of reciprocating, especially, and high conversion efficiency will be there. So these are the main advantage you will get. Next, it requires less maintenance and handles the any quantity of air it can handles, and it requires more space due to larger impeller. So this might be the one disadvantage you may take, that is requires more space due to larger impeller. So this is one disadvantage compared to other superchargers. So these are the advantage and disadvantage of centrifugal supercharger. Next we'll go for Roots supercharger. See, this is about root supercharger. So root supercharger, it consists of cylindrically shaped lobes. We can say ellipsoid lobes or epicycloid rotors. So lobes will be there. So it will be rotating in opposite direction. One, if this one is rotating like this one will be in another direction. So direction will be in one will be one opposite direction. These two lobes will rotate in a common housing. For these two lobes we will have the common elliptical housing. So housing will be common. Air enters the space between these two lobes, space between the rotor lobes at the inlet, and it is carried around the rotor and discharge force. So here it will comes, and here it will comes out of the rotor. Uh, it should be noted that the no compression occurs in this process because uh, there is no compression over here because extra work has to be done. So compression take place only when the discharge port is open. So while suction there is no compression, while the discharge port is open then only your compression will take place, and pressure rise almost instantaneously, remember, because of this rotational or cavity whatever the formation will be there. So initially it will go over here and there won't be any compression. Whenever the discharge port is open, it will come over here, it will compress us instantaneously, and it is going to the exhaust port, and exhaust port opens, there might be a backflow of the air due to more work is required for the compressing the air. Sometimes you may encounter backflow of work. Whenever the backflow of air will be there, then more amount of work has to be done. That is more amount required, more work input is required to compress this air. The extra work whatever it is required to compress air, it will be given from the engine or exhaust energy only. Sometimes there might be a certain leakage between your lobes, might be you may encounter in the housing of the blower. So these are the disadvantage. Noise also might be there produced. So nowadays instead of two lobes they may use three lobes. Helical lobes might be using. So this gives an air supply at reduced noise level, and pulsation in the air supply also reduced. The blower is run about 1.5 times that of engine speed. The rotational speed will be 1.5 times that of engine speed. So this root blower is highly suitable for the pressure ratio in the range of 1.1 to 2. So 1.1 to 2 if you want a pressure ratio, then the root blowers are very suitable. It is simplicity, low cost, good mechanical efficiency can be obtained. There is no lubrication required over here. In earlier case we need a lubrication. Here no need of any kind of lubrication. This will work around low moderate RPM like 4000 RPM, and the blower is bulky and heavy in nature, and volumetric efficiency decreases rapidly with the increase in the pressure ratio. Remember, if the pressure ratio goes beyond 1.8 or 2, then volumetric efficiency rapidly decreases. That is the main disadvantage you can achieve from this type of roots blower. Okay. The combined effect of the compressibility of air and the backflow causes volumetric efficiency reduce as low as 50 to 60%. You can get at pressure ratio of 3:1. Okay, so these are the types of blow type. So advantage, as already told, simple in design, low capital and maintenance cost. Volumetric is efficiency is high, and better balancing is possible whenever the pressure ratio is in the range of 1.1 to 2. This point, remember, whenever the pressure ratio is between 1.1 to 2, if it is goes beyond 2, then volumetric efficiency is going to be reduced as low as possible. 50-60% you may get beyond 2 pressure ratio. Chances of leakages are more. This is the disadvantage, as already told. So sometimes airmen might be leakage may take place, so that we can't achieve that kind of pressure ratio. Same pressure, 1 atmospheric pressure may go inside the cylinder. As pressure increases, volumetric efficiency, that is pressure ratio increases, volumetric efficiency of supercharger decreases. So this is the disadvantage. These two are disadvantage. These two are the advantage of your roof type of supercharger. Next, we'll go for a vane type supercharger. So in this vane type of supercharger, we'll have vanes instead of roots. We'll have a globe. We will have the vanes over here. So eccentric kind of lobes will be there, and drum will be there. Air is going inside over here, out will be there. So this is the body of your vane, and this is the casing of your supercharger. So in this type of supercharger, it is called as a positive displacement type of supercharger. So this consists of a rotor rotating in a large cylinder. So rotor which will be there rotating in a large cylinder, which has a six slot, remains in contact with the casing at least one at a time. One point at a time, at least one point at a time, it will have a contact with them. The axis is mounted eccentric axis. We can see you just studied this part. I just going to repeat that one. Already you have studied this vane type of pump. So eccentric type will be the center is eccentric. The blade slides radially in and out of the slot. So whatever the slot is provided, in and out, here the slot will rotate eccentrically whenever it is rotating eccentrically. So air will comes, and it will goes over here, and it will compresses, then it is going outside the engine cylinder. So whenever the blade moves out air induced between the space between the blades, which is increasing. So air is discharged when the space are decreased near the exhaust side. So whenever air is going this side, space will be reduced, as the compression will take place. So due to vanes, the flow is pulsating and noisy. Speed is limited because of radial motion of the vanes. So nowadays, vane types are these types of superchargers are absolute. So most of the superchargers what we are finding in the market are most of them are centrifugal type of supercharger. Positive displacement are not at all suitable for low application. Okay. So it is suitable for high capacity engines. High pressure ratio is possible and delivery large quantity of air, and maintenance cost and power requirement is high. So The veins rub against the cylinder wears out rapidly. So first two are advantage, next two are disadvantages. Okay, so this is how types of superchargers. So very important. One is objective of supercharger, then methods of supercharger. So many times they have asked that question, methods of superchargers. Draw it neatly. Then types of superchargers, vane, root, and centrifugal types. Okay, reciprocating type I have not explained. You can go through any textbooks of supercharger. So if you want, you can add that one also. Okay, but that are not useful in nature. Okay. Next, we will go for the limits, supercharger limits. What are the limits you can impose on supercharging? So that we'll study over here. Supercharger limits. See, now you know that is we have to increase the pressure. How much increase the pressure? At what pressure you can limit this supercharging of the air? So that is we should know. Why you have to limit? Because you know already I have told, because of knocking. So knocking will take place and it will reduces the engine life. Our thermal loads will be there inside the engine. That material has to withstand that thermal load or mechanical loads. So, based upon this limits, that is knock limit and thermal loads, we are having the supercharger limit. So usually in SI engine it is limited by the knocking limit, whereas in diesel engine it is limited by the thermal and mechanical loads. Okay, these are the conditions we will have. So separately, SI engine supercharger limits are different. In diesel engine, CI engine supercharger limits are different. So SI engine because of knocking limit, whereas in diesel engine because of thermal and mechanical loads limit. So because of that, we will have the supercharger limit. Usually, one of this limit it is reached earlier than other limits depending upon the type of engine and design of the structure and cooling arrangement, etc. Okay, then for spark ignition engine, knock limit is usually reached first, whereas diesel engine thermal loads are reached first. That we have to take it. Then if supercharging is to be done existing engine, it is necessary to analyze the factors that limit the extent of supercharging. So because say while doing any kind of experiment, we are done the experiment on supercharging, especially turbocharging. First we have to check how much pressure ratio we have to go. That is very important. We have to calculate a maximum pressure limit or the minimum pressure limit. We have to study that part, then only we can purchase or we can select that type of compressor and turbines. Then we can run that turbocharger or supercharger on the naturally aspirated engine. So we have to study that, or we analyze several factors so that engine knocking can be avoided, and how much energy exhaust you may have, how much pressure ratio you have to get. So all those things you have to study. So all those things will withstand your loading, thermal stress, durability, reliability, fuel economy, etc. Okay. Whenever you do supercharging, one important factor, because supercharging will does the more amount of air, it will create the turbulence inside the engine. So whenever the turbulence created inside the engine, what will happen? It will reduces the delay period of combustion. You have studied the delay period in the SI engine. That's once the spark is ignited, it will take some time to initiation of this combustion. So that time is called as ignition delay. So that delay period, if it is more in SI engine, then what will happen? Then the knocking may lead into picture. So it will reduces that delay period, and it will result in engine knocking at high pressure. Okay. So to increase this supercharging pressure increases the tendency to denote. So supercharger limit, it is for 1.3 to 1.5 bar for SI engine whenever you corresponding to 30 to 50% supercharging. So that is the limit we can go for SI engine 1.3 to 1.5 bar. Next, we will see supercharging limits in SI engine. See, before going for SI engine, we will check what are the things. The degree of supercharging. Okay, the degree of supercharging in SI engine is chiefly limited by the knock that we know. The increase in the pressure, which will lead into temperature also increase because of supercharging, which will reduces the delay period, as already we know. So consequently, what will happen? Engine as the knocking tendency can increases because of delay in the ignition period for SI engine. If you have a delay in the ignition period, means combustion will take place more rapidly. So unburned combustion will be compresses more, hence knocking will be very tendency of knocking will be very much high. So this locking limit is depending upon the type of fuel use, mixture strength, spark advance, so many other factors will be there. One among this supercharging also will come into picture. So different fuels, different knocking tendency fuels can be used. Some are more sensitive to the increased pressure, other might be increased temperature. So we can see over here in this graph, so which will shows the for different kind of fuel. See, benzene is there, isooctane is there, isooctane is there, then cyclohexane is there, which is plotted against the mixture strength. Mixture strength means see, 0 represent your chemically correct mixture, that is the stoichiometric mixture. If it is air is more, this side fuel is more. Okay, this is mixture, air fuel ratio mixture. HUCR means highest useful compression ratio. What the highest useful compression ratio we can use for particular fuel? Okay, usually we are using petrol. Petrol means isooctane. So highest useful will be 9.5 or 9.5 up to 9.5. You can use that isooctane. Okay, 9.5. So this is for petrol, whereas other we can see benzene you can use up to 15 compression ratio, whereas cyclohexane you can use up to 9. So this tells about what are the compression ratio we can use for different fuels, whereas in this figure what it tells, it will tells the mean effective pressure. We can see on the y-axis mean effective pressure for different fuels at a different intake temperature. Depending upon the intake temperature, how much intake pressure, mean effective pressure will be there for different fuel. It can be seen that volatile petroleum fuel of high octane number, volatile fuel with high octane number, see here octane number is 87, this one is 73. See, high octane number will have uh, the knocking tendency is reduced as the octane number is increases. You can see that knocking tendency is reduced and pre-ignition tendency also reduced at a very high and lean mixture. Lean mixture we can see IE mixture, rich mixture, and very lean mixture. We can see tendency can be reduced, and hence we can use high compression ratio, and mean effective pressure can be increased. So this is about your basic fuel, this one. So alcoholic fuels might have knocking is reduced at rich mixture because of use of cooling effect will be there, high latent heat will be there of these fuels, hence knocking can be reduced. So once that fuel selection will be proper, then only we can go for supercharging, because we will come to know that once this will have the strongest knocking tendency for that fuel, uh, then we can use for supercharging. So strongest knocking occurs near chemically correct ratio. See, near chemically correct ratio we will have the less compression ratio. That means if it is chemically correct ratio, if you are going to maintain, then the knocking tendency may increase also. Or very rich and very lean mixture might have a non-knocking characteristics. Because of this, we can use the supercharged engines. So since we are having the richer fuel, this side we can increase the compression ratio. That means knocking tendency can be reduced on the richer side. Okay, so richer side, so while you are doing the supercharging, so from this graph we can say that we have to maintain the richer side so that the knocking tendency can be reduced. So that is the one thing we can see. And a slight reduction in the lean mixture result and irregular and intermittent engine operation. So usually we won't go for a leaner mixture. Most of the time we will go for the richer mixture. Leaner mixture will lead into the intermittent and irregular kind of operation. So this can occur with early as 20% XSR. So the use of rich mixture will result in a high specific fuel consumption for a supercharged engine. So because of that one, the fuel consumption will increase because we are using the high richer mixture. That means high fuel we are utilizing, and so your fuel consumption is going to increase to avoid that knocking. So knocking limit of SI engine also affected by the ignition timing. So ignition timing also it is affected, and thermal load of the engine, high intake pressure and temperature also ignition must be retarded. So these are the things we have to take care while supercharging limits for your SI engine. Okay, and in general we can say that supercharging pressure is in the order of 1.3 to 1.5 bar can be used for SI engine with 30 to 50% of supercharging. Okay, next in CI engine. So in CI engine, as already told, it is because of your thermal loads we have taken care about, because in CI engine only air is going inside the cylinder and fuel is injected at the so delaying the ignition period will lead into your lesser tendency of knocking in CI engine. Okay, so here knocking is not that much important when compared to SI engine. Here it is much more important of stresses, thermal stresses what I are getting because of that heavy bulky nature materials, bulky engine can be obtained for supercharger. Okay, so any increase in the pressure or temperature decrease the ignition delay, engine decreases the ignition delay and engine runs smoothly. The limit of supercharging for C engine is reached by the your thermal load or mechanical loading. The temperature of the piston and cylinder is very high, which will result in stopping of the piston rings and heavy liner wear. Okay, so that has to be. In this figure we can show that effect of supercharging. We can see supercharging pressure, that is 0.25, 0.5, 0.75 bar in x-axis extra pressure. This is the extra pressure. APC, it will tells about, A tells about compression pressure, B tells about firing pressure, and C tells about mean indicated pressure. So this figure shows the effect of supercharging pressure on compression firing pressure. The load on the bearing is increased due to increased pressure in the cylinder. See, as you increase the supercharging pressure, what will happen? Your compression pressure also increases. Firing pressure, see, it is also increases a lot. If it is goes beyond 1.75, still it is increasing. That means that much amount of your stresses will be there on your material. Loading stresses or bearing stresses will be coming to picture. So maximum cylinder is about 85 bar. So material characteristics will comes into picture, material stress will come into picture. So this material stress is limited, maximum it is limited to 85 bar. We can't go beyond 85 bar. That means we can't go beyond 1.5 or 1.6 bar pressure, increase in the pressure. Beyond that we can't go for the, that is the meaning of this graph. So what will happen, we can go up to 1.51 means more than 1 atmospheric will be there, plus 1.5 you can go up to 2.5, that is the maximum limit. Means In general, we can say that some factor of safety. We can go for a 2 atmospheric pressure with compression ratio of 15:1. This is for 15:1 compression ratio. So up to 2 bar we can go for 2 atmospheric pressure. We can go for a supercharging of the engine. So otherwise you will feel the thermal stresses or bearing stresses will be you can achieve in the material, and failure of the material may take place. So durability, reliability, and fuel economy are the main consideration while limiting the degree of supercharging in C engine. Remember, in C engine we are mostly concentrating about durability, reliability, and fuel economy of the CA engine. Increasing the maximum pressure in cylinder decreases the reliability of the engine. So this also increase in the rate of heat release rate, hence the thermal load of the engine can be increased. Okay, so for intake pressure greater than 2.5 atmospheric are not advisable in a C engine. Up to we can go up to 2, means up to 1 only, because it will be limited to C80 bar. So beyond that some kind of factory safety is required. So beyond that it will lead into some other issues. Material failure may take place, thermal failure we can say. Fuel economy is also a very important factor in deciding the degree of supercharging. We can't go more amount of fuel. So intake pressure, if it is less than 1.5 atmospheric, then the cost and complication of supercharger what we are going to use, that is not justifiable. Means if it is go 1.5 beyond 1.5, so the failure of so many parts will be there. So with the cost what we are purchasing supercharger, that might not be justifiable in the later stage for CI engine. So these are the things we have to consider, or these are the limits we can put in a SI engine and a CI engine. So this is about limits we can tell about CI engine and SI engine. Next, effect of supercharging on the performance of the engine. See, this is very important. One more thing. Once you do the effect, once you done the supercharging on the engine, so on which parameter it will affect? We are considering three kind of things. One is power output, then mechanical efficiency, then fuel consumption. These are the things we are taken care. That means effect of your supercharging. First we will go for power output. So we can see over here graph. So that is a ratio of supercharge with respect to power and efficiency. Efficiency means thermal efficiency. See, power output of the supercharged engine is higher than your naturally aspirated engine. That you know that one. Due to following reason, because the amount of air given per cycle is more, mechanical efficiency is improved because of volumetric efficiency increase, and during the gas exchange some of the work done on the supercharger is recovered, and supercharging will result in better scavenging, remember, and reduce exhaust gas temperature in the engine. This residual gas fraction helps in better combustion, and reduced temperature improves the volumetric efficiency. So above mentioned, now whatever I told above mentioned effects are common in both petrol and diesel engine. However, in petrol engine, supercharging results in a tendency to knock. So in contrast to diesel engine, it will run smoother and able to utilize low fuel air ratio supercharged engine. Okay, so increased reliability, durability, better fuel consumption, some other benefits we can get in the supercharging diesel engine. So as the ratio of supercharge increases, what will happen? The total fuel consumption, see over here, sorry, this power, the power, it will increase us up to a certain limit of ratio of supercharge, then it will decrease us. That means after certain limit only we can use the supercharger maximum limit. After that we can't use. But in contrast to that one, efficiency, see, ratio of supercharge increases, the ratio of this efficiency is keeps on decreases. So we have to fix with respect to what power you want, how much power extra you want, how much with the cost of efficiency, that you have to take care. Okay, why it is efficiency is decrease? As I told, in supercharger, we want to operate in the richer region, means we are giving the more fuel than the required fuel, hence more input will be there, hence power output also increases, heat input also increases, hence efficiency is keeps on decreases because of we are working in a richer region. Okay, to avoid that knocking, hence your efficiency is keeps on decreases irrespective of increase in the power output. So this is about your supercharger. Okay, so you have to check up to what pressure ratio you can increase that supercharger. Okay, so this is about power output and efficiency of the engine. So next will be your mechanical efficiency. So mechanical efficiency, we can check over here. It is given with respect to your engine speed and the pressure. Okay. So mechanical efficiency, an increase in the supercharging pressure, which increases the load. Hence, larger bearing areas, heavier components are needed. So this increases the frictional force. Remember, see what will happen as you are increasing the supercharging pressure, it will increases the load. So we have to change the bearing load, so means larger component of bearing load to withstand that load, it is known. So larger bearing means the frictional forces are more, the frictional power going to increases. Okay, however this increase in BAP much more than that of increase in the frictional forces. That means whatever output you are getting, brake power, that is more compared to that of whatever increase in the frictional power. And so typical value might be in the range of 11% increase, 7.5% increase you may obtain for petrol as well as diesel engine compared to your frictional forces. So thus mechanical efficiency, remember, thus mechanical efficiency of a supercharged engine are slightly better than that of a naturally aspirated engine. Okay, so these graphs it will tell us about mechanical efficiency obtained for a 6-cylinder CI engine of a supercharged engine. So we can see lower load will achieve 60 as the engine speed increases, your pressure is keep on decreases. So this is about, it will tells about a brake mean effective pressure for a supercharged engine. Next we will go for fuel consumption. So that is the specific fuel consumption. So the power required to run the superchargers varies with the different arrangements of the supercharging. So how you can achieve that supercharger arrangement we have seen. So it depends upon different types of arrangement. If the supercharger is directly driven from the engine power, that is the first method what you have discussed, then uh, what will happen, and part loads of the compression of the supercharger and not utilized fully. So this will results in lower this will result in a loss in the power, because at part load condition what will happen, more amount of power is given to your compressor only to run the engine, and so power loss will be there, and so more amount of fuel might be consumed for a mechanical driven superchargers at part load condition, and so fuel consumption is going to increase during the part load condition. So in addition to this, the fact of highly supercharged auto engine uses rich mixture. So as already told, in SI engine we want to work in a rich mixture to avoid the knocking and free ignition, so that obviously the fuel consumption has to be go, that means higher, that is higher specific fuel consumption will be there for your supercharged engine in a SI engine. So we can say that in spite of better mixing, or in spite of better combustion, in spite of reduction in a delay period, a mechanical supercharged auto engine will have almost have a specific fuel consumption higher than that of naturally aspirated engine. Understood? Because in a part load we need more, whatever power generated, extra power generated, it is given for to drive the compressor only, so no output increase, but fuel consumption has to go, it's the same level. And as well as due to knocking limit, we are working the engine in a richer condition, that means more amount of fuel is been introduced. So in spite of whatever advantage we are getting from the supercharger, that is better mixing is possible, combustion is better, reduced delay period will be there, so mechanical supercharged auto engine will have almost higher specific fuel consumption when compared to that of naturally aspirated engine. So these are the effect on the engine. So specific fuel consumption, what about CA engine? The specific fuel consumption for CA engine is somewhat it is almost equal or lesser than that of naturally aspirated engine because of better combustion and increased mechanical efficiency. Okay, so in CI engine it may reduce, whereas in SI engine it will increase. So whenever you use another type of supercharger like turbine driven supercharger, so whenever you use such kind of methods for supercharging, that is turbocharger, so any power it doesn't require, right? So whatever extra power does, it is going to the engine power only. So moreover part of the exhaust energy is utilized, thus giving almost better mechanical efficiency and thermal efficiency as well as fuel consumption. So this turbocharger will increase the efficiency when compared to that of supercharger. Also it will improve the fuel consumption. So turbocharged engine, if it is properly designed, then it will give the lower specific fuel consumption as well as higher efficiency compared to naturally aspirated engine. So this is the very important thing, so that you have to take it. Okay, so now onwards, now we will study what you mean by turbocharger and its applications. Turbocharging. So turbochargers, as already mentioned, it is a type of supercharger only. So that is the second type, second method. So what is, so it effectively charges the incoming air, which is a definition of a supercharging. That is increases the density of air. So same principle, whatever the supercharger principle is there, same is there, but the power requirement, what is the power requirement for that supercharger device? It is taken from the exhaust. That is a thing difference. That is only the difference. So you can compare this turbocharger like a hydroelectric dam. We can compare to that one, just a comparison where you can convert the power from water into mechanical energy. So how it will works in hydraulic electric dam? So hydroelectric dam sends the water to the turbine, hydroelectric turbine. Okay, the turbine design redirects the flow water into circle which caught by the fins or blades. Okay, the water turns these blades, which turns the drive shaft. So when water is released, most of its energy to the blades, the water then exits the turbine through the port at the center. So that means some water energy will be there, okay, at high level, then it will hit on the blades. So blades are rotated, that is its kinetic energy, whatever it is having, the water kinetic energy is having, so that will be it on the blade and your turbine blades are rotated. Similar fashion, the similar fashion your turbocharger also will. So in turbo cars, whatever we are told how the turbine will rotate, same way it will affect. So in this turbine, exhaust energy will be there. So exhaust energy, what will happen? So this exhaust energy will be at a higher pressure. So at higher pressure, exhaust energy now higher than your atmosphere pressure. So that higher pressure exhaust energy, it will comes and hit the turbine blades. So that energy is, it has been utilized by the turbine. So turbine blade will rotate. That turbine blade will be rotate and turbine is coupled to your compressor, and so your compressor will be given the power from your turbine. Okay, now how we have to control that? That is controlled by wastegate or blow off valve. We will call so boosting, because we can't go beyond in the natural aspirated engine. We can't go beyond 1.5. So how to achieve that 1.5 pressure ratio? We can achieve by mass flow rate of exhaust. So that mass flow rate of exhaust, it is controlled by a one valve that is called as wastegate or blow off valve. Through that blow off valve only we are going to control the turbocharger intake. Okay, so one of the disadvantage will be there in your turbocharger, that is since exhaust it is two parameters will be there, two components are there. One is turbine, one is the compressor, which will be held together on the common shaft. Hence, because turbine will be working in a high temperature region, there will be transfer of heat will be there. Okay, from a turbine to compressor through that shaft. Hence, what will happen while super charging your hair, it may get heated up. So superheating might be there. So there might be need some kind of intercooler. It is needed. So that might be the disadvantage for this system. And also some turbo lag will be there. So that is also disadvantage for your turbocharger. So these are the disadvantage, but this turbocharger due to that disadvantage also we are using in a very effective manner. Okay, okay, this is about turbocharger. So we will have the engine, intake valve, exhaust valve. This is intake manifold, sorry, exhaust manifold. This is intake manifold. Remember, this is intake man. Air and fuel mixture will be there, or air mixture only you can say. Nowadays injection, so it will inject over here. Air will be coming over here. Here compressor will be there. Here turbine will be there. Shaft will be common shaft coupled to this. Okay, so turbine, exhaust at high pressure exhaust, it will have the energy. So that energy of the exhaust gas, it will convert it into turbine work. High pressure energy, it will hits on the turbine blade and it will convert it into rotational motion. So rotational motion, it is going to drive shaft of your turbine. That drive shaft is connected to your rotary. Okay, and this rotary will be the rotary compressor will be there. So it is going to that rotary compressor. So this compressor will runs and it will takes the air from normal atmospheric and it will compresses and it is going inside the cylinder. So in this way your turbocharger will work. So the exhaust gas whatever entering into the turbine inlet side of the turbocharger through a pressurized chamber in a series of filters, it is provided, and nozzle blade angle rings concentrated on the exhaust gas on the turbine wheel. So some kind of nozzle sometimes we have to provide so that it has to concentrate on your turbine blade so that more energy it can be utilized. The movement of the turbine wheels rotate the shaft in which rotates the impeller of your compressor. Okay, a part of this air goes to the seal outside the turbine. Okay, because sometimes leakage might be problem might be there. So as the impeller rotates, air will be sucked from your atmosphere through the center of the impeller. Due to heavy rotational movement experienced is the centrifugal velocity which pushes outside radially and gains that pressure, and more pressure will be there and more pressure it is going inside your engine cylinder. Okay, this is how your turbocharger will acts. So this is the working principle of your turbocharger. Okay, and here see now we want to control this pressure ratio, say 1.3. So how you can control? You have to control the speed of this shaft. How you can control the speed of this shaft? You can give only few amount of exhaust gas, say, especially in higher speed or higher load condition, because the pressure is more quantity of exhaust will be comes into picture. Whenever the more quantity of exhaust will come into picture, then the more pressure will be created, and rotational speed will increase as in the turbine. So how to reduce that one? We have to provide one exhaust waste gas. So this wastegate, it will allow only fraction of exhaust gas inside your turbine. So hence you can control required pressure ratio through this wastegate. How much you want, that much exhaust only it is going to the turbine. The remaining is going to your exhaust manifold. So in this way, gate valve is provided. So this can be actuated based upon your intake condition and speed condition. So many things parameter will be there. So based upon that, this exhaust waste gas can be controlled. Okay, this is how your turbocharger will works. So turbocharging limitation, that is turbocharging needs a special exhaust manifold, because exhaust manifold also redesigned with respect to that. We need to change the length, and some waste gate has to prepare, and control mechanism you have to give for that wastage of exhaust. So hence exhaust gas manifold has to be uh, reached, and larger pumping elements or nozzles are required, so inject more fuel per unit time. So this will overloads the cams and other components of the engine. And turbine blade efficiency is more sensitive to the gas velocity. So variation in the gas velocity in the regular basis, it will affect the turbine blade efficiency. So that means conversion of the isentropic process may not be able to done. So that is the thing. Then fourth disadvantage or limitation is difficult to maintain the satisfactory air charging over the complete operating range of the engine, because of a more amount of variation in the fuels consumption or air consumption depending upon different types. It is difficult to maintain the satisfactory air charging, means air supercharging. It is difficult to maintain at constant pressure ratio. It will keeps on changes. Comparison between turbocharging and mechanical supercharging. So these are the table. It will give the comparison between the turbocharging as well as mechanical supercharging. So whenever you talk about turbocharging, the energy of the exhaust gas used to run that supercharger or compressor. So it needs some wastegate control to maintain that pressure ratio, and it requires special exhaust manifolds, uh, and in CI engine it reduces the smoke, and blade erosion take place due to entry of dust particles, and larger pumping elements or nozzles are needed. This will overload the cams. Pressure ratio is high. We can achieve the more pressure ratio compared to supercharger, and it is bulky because two components will be the turbine is there, compressor is there, and wastegate controller mechanism is there. So many things will be there, so hence it is bulky and heavy in nature, and easy scavenging can be obtained turbocharging compared to the supercharger, and poor response to load change. So whenever the load change, there will be response will be very poor in the turbocharging, so when compared to supercharging. Whereas in supercharging, mechanical energy prime mover is used, that is gears are used from engine to drive your supercharger, and it does not require any wastegate control technologies in the exhaust manifold. We need not change when compared to turbocharging. In C engine, it reduces the knocking tendency, no blade erosion problems when compared to this one, and fuel injection modification is not required. Hence cam overloading may not be there in your superchargers when compared to turbochargers. Comparatively, whenever the low pressure ratio only we can use in superchargers, and it is light and in compact in nature, because less components will be there, and so it is light and compact and compared to turbochargers. Scavenging is difficult, whereas in turbocharger scavenging is very grateful, and better response can be obtained due to load change. So these are the comparison between your turbocharging and supercharger. Next we'll go for the intercooler and turbocharger lag. Intercooler, whenever you talk about intercooler, because in turbine means sorry, in turbocharger, intercooler is a must, because compressor and turbine is working. Turbine is at a hot range, hot temperature range, and compressor is at a low temperature range, and so there will be a transfer of heat might be taking place to the air, and so your air temperature will rises, so you have to bring back to the normal initial temperature. So that reason we need some kind of intercooler. So intercooler will be integral part of this turbocharger. So the power that a non-intercooled turbocharger created could be maximized by using the intercooler, because without intercooler, if you send that pressurized air due to high temperature, density of air once again it is comes below, and there won't be a much power output increase. Whatever you are expected, it may decrease your power output. So intercooler is necessary for a turbocharged engine. Okay. An intercooler can be compared to your radiator type, because radiator where your can fins are there, or will be where it will takes the heat and it will bring back to the initial condition of your fluid, and it is like radiator type of intercooler will be there. So intercooler will fits on the intake tract, so to the engine from the supercharger. Generally only centrifugal supercharger can be included intercooler due to their mounting options. The intercooler dramatically cools the compressed air and in effect packs the air closer together. The volume is V, T is the temperature, V are the perfect gas equation, V1 by T2, that's equal to V2 by T1. For a now let us consider 2 liters of air at 200 degree Fahrenheit, and intercooler that cools it to 60 degree Fahrenheit. So while substituting what will become, we will get the X as a 2.54 liter. That means what it will test, the intercooler will boost the power of the engine. That means it will boost more oxygen for the same value. Hence cylinder can therefore can create a large and more vigorous explosion, therefore produces the more power. So intercooler can come in two types. One is A to A and A to water. A to air system are ambient air or directly cooled the pressurized air in the air water system. First cool the water with the ambient air around the car, and then it is filtered into the internal coolant system where the cooled water is cools the charged air. So in this way we can cool the your pressurized air. So then we'll have the one more concept, that is turbocharger lag. So I won't tell much about that one. So you just go through the nodes. So this turbocharger lag, it is a phenomena encountered in a turbocharged IC engine whereby an operator experiences a short delay of full engine response after pressing a accelerated pedal. That means whenever you, for a turbocharged engine, whenever you press the accelerator pedal, you won't feel that that much power input increase. That might be a slightly delay in the response of your power increase. That lag is called as, that delay is called as turbocharger lag. So this occurs because turbocharger relies on the pressure of the exhaust gas, because once you started the engine it will take some time, because exhaust gas has it has to get some kind of pressure to run that turbine, hence it is needed some time to achieve that pressure. So that time is known as spooling of time, you will call spooling of time. So once that spooling of time is achieved, then only it is turbine will work, and turbine will transfer that power to compressor, and compressor will compressors your air. So turbo lag is considered negative characteristics in automobiles. So and one heat engineers strive to mitigate the number of different ways. To understand this turbo lag, a working knowledge of how turbocharger works, why they are used, that all those things you should know. So idea behind this adding turbo system to an engine is augment the power generated in the engine alone through simple combustion. So it is a basic concept of your supercharging. A turbo will works on the exhaust gas, so then it will compressor will be used to compress, so it will take some kind of time, hence that time is known as spooling time, and that is known as your turbocharger lag. So that is about your turbocharger lag. So in this way, so the most common way engineers get around turbo lag is simply to use lightest component as possible, because less inertia means less lag will be there, and more complex way if you are using, then lag may increase, and more complex way is to pair a large turbo with a smaller one or with a supercharger. The instant or near instant spooling of the secondary unit helps the component for the lag, while the larger one build up the pressure, minimizing the or eliminating it completely. So this is how you can avoid this turbocharger lag or turbo lag. Okay, so this will complete your supercharger and turbocharger. So question for this class. So first to 4 and 7 16 MB. This is the question. MB 01 to 04. Effect of supercharging on power output. 05 to 07. Effect of supercharging on mechanical efficiency. 8 to 12. Effect of supercharging on specific fuel consumption. 14 to 16. What are the supercharging limits for SI engine? 18 to 20. What are the supercharging limits for CI engine? 20 to 25. Method of supercharging with the turbine driven engine compressor. Supercharging with turbine driven engine exhaust. Then 30 to 32, within a sketch a method of supercharging with the turbine and compressor coupled. 33 to 36, this is the fourth type of method, that is supercharging arrangement with the engine, turbine and compressors are coupled together. Okay, so this is the fourth type you have to check, that is 33 to 36. Next 40 to 44, root type supercharger. 45 to 47, vane type. 49 to 51, centrifugal type of supercharger. 52 to 55, compare turbocharger with mechanical supercharger. 57 to 59, with a neat sketch explain the construction working of turbocharger. 60 to 62, advantage and disadvantage of turbocharger. 64 to 67, short note on intercooler, and diploma students write a note on turbocharger lag and how it is can be controlled. Okay, so these are the questions, submit within the time. Okay, thank you.